Okay, this is workbook 24.2, which is the converse of the proportionality theorem. Basically, what that's meaning is that the converse says, because before we had, if these lines are parallel with two triangles, then it makes proportional triangle, like makes lots of proportions. And this is saying instead, if there are lots of proportions, if it's proportional, then they're parallel. And that's the main idea here. So it's saying that if these are all proportional, then that's parallel. And let's just go right to the thing. So we're supposed to do a proof of it. So notice here we have that BD and BE are from the smaller triangle, and then DA and EC are the part of the bigger triangle, and we're supposed to prove that these two lines are parallel. So we start with given, because that's what we always start with. Then we can do the reciprocals of those proportions also. Then we can add them, basically saying this part plus this part equals the whole thing. But then they also kind of did a bunch of other stuff in there, kind of like we did on the last thing. We substituted it in, we added them up, and then right here, so this one is kind of the same type of thing that we had last time. This is just the segment addition postulate, saying that if we can add them, and then we can replace them. So this is going to be substitution. Angle B is the same thing as itself. That's always reflexive. Then the triangles are similar, and that is based on correspondence of angles, or similar triangles are, let me see, corresponding angles are, let me see, we don't want that one. We want, for this one, we have that they're similar, and that would be a similarity statement. So there's only one similarity statement. And because they are similar, then that means that they are, the angles are the same. So corresponding angles of similar triangles are congruent. And because of the angles are congruent, then that means that they are parallel. So it is the converse of the corresponding angles theorem. So, yep. Let's try that. It's going to be wrong. This is my fear always. Let's find out. Yep, we got it. Okay, good. So that was 24.2. I am going to pause. And as a bonus for you, for watching this video, you get the checkpoint also. So you can open up the checkpoint and follow along with me. So use the diagram and information to complete the proof. So we know that AD is proportional, is to BD as AE is to EC. We want to prove that they are parallel. So this is the converse. So let's see, we went through here and we said, so we had this angle addition postulate. So then right here, when we did the last one, it was substitution. Then angle A is the same as itself. That's reflexive. Then this has to be a statement about similarity. So there's only one statement about similarity. And now that we know that they're similar, we can say that corresponding angles of the similar triangles are congruent. And then therefore that is the same thing. This is almost the exact same thing as the last one. So, okay, so that was that question, almost exactly like 24.2's question in the first place. So examine that following figure and fill it in. So the measure, okay, so do we have numbers here? We have an option. Okay, cool. So EB, so let's see, EB, we want that. So let's see, 32 to 48. So this is where I'm going to do the proportions. So I have 32 over 48 equals 40 over the X. The Maui thing that I talked about would be 40 times 48 divided by 32. So I am going to go and I will do, so I'm going to do the diagonals. So I'm going to do that, this 40 times by 48 divided by 32. So 40 times 48 divided by 32. Put that in and I got 60. So this thing right here is 60. So EB is 60. And then units by the, and so it was a proportionality. And so BC, that's the whole thing. So we'd have to add them. 60 plus 40 must measure 100. Okay, that should be it for that one. And then we have to do, so now they're parallel, we have to prove that they're proportional. And so we went up here, they had this proportionality statement, they said addition stuff right here. This was substitution. This is almost exactly what we did on the workbook. And then this was expanding the fractions so that each one of the things in the top was divided by the denominator. So that's expansion of fractions. Then that's division, because BE divided by BE or BD divided by BD is 1. Then we can subtract from both sides. This is, again, it's very similar to what we did. And then they flipped it. That's the reciprocal. And that's it. We're done with that one. So that was checkpoint 24. All right, that was all of workbook 24. So good job. Hold on a gall darn minute. What did I get on this? I got an 89. We can go back through and see what we did on number 2. It says that something was wrong. It's probably this converse of the term. There was probably another reason I didn't see in there. I could do it again. Let me hear you do it again, because we know the first 2 are right. So if you're doing that, you can do it again and watch the first part, and then you need to go back and do just that part. So the correction on that one was the triangle proportionality theorem, which makes a lot more sense. I thought the other one didn't make very much sense, but I'm like, well, I guess if that's all they have. All right. So then now you should be getting it right. And they mixed up the order for me. They might do the same thing for you. So now we should have 100%. Woohoo! All right. So there's workbook 24 done.